Okay, so when we're looking at linear graphs, we're essentially looking at relationships that have a correlation. So something like time spent studying, performance in exams. And we'd expect to see a correlation between the time that you spend studying, so the more time you spend studying, the better you're going to go. So with linear, basically explaining the relationship between x and y, so this little part here, and as this went up and this went up, this went up. So basically, in order to explain the nature of the relationship between time spent studying and your performance, with linear graphs, we've got a rule. And the formula, well, not really the formula, but the format of that rule is y equals mx plus c, where m is the gradient and plus c, or minus c as it might be, if the gradient is negative, is the y-intercept. So remember, the y-intercept is where it crosses, where the line crosses the y-axis. So it'd be that little point there. So where the line crosses the y-axis, x always equals 0, and y always equals whatever c is. So let's have a little look here. If our rule was y equals 5x plus 2, so whatever I plug in for x, whatever x is, just say x is 2 hours spent studying. So 5 times 2 is 10, plus 2 is 12. If x is 2, so 5 times 2 is 10, plus 2 is 12, y will be 12. If x was 5, 5 times 5 is 25, plus 2, y will be 27. So having a little look, we can see here that there will be a positive relationship like that. As x goes up, y is going to go up. So the gradient of that line, the gradient of that positive line is 5. And we can see already that positive 2, the y-intercept, so bear in mind where it crosses the y-axis, where the line crosses the y-axis, x will be 0, y will be 2. That's kind of easy. Now it's time to work out what happens, how do we calculate the x-intercept? So working out the x-intercept, that's the point at which the line, whatever the line is, we'll just draw a line like over here. That's the point at which the line crosses the x-axis. The point at which x is a number, but y is 0. Y is 0, that's where it's crossing the x-axis. So to do that, we're trying to work out what's x when y is 0. And we just use substitution. So 0 equals 5x plus 2. Then we just use our rules for solving linear equations. So I want all the numbers on one side and all the letters on the other. So the first thing I'm going to do is get rid of positive 2. To get rid of positive 2, I minus 2. If I took 2 away from here, I've got to take 2 away from there. 0 minus 2 is just minus 2 equals 5x. So if 5 times x equals minus 2, I divide that one by 5 to cancel that out, and I divide this one by 5, and I've got my answer. X equals, I just swap sides on them then so that I can conform to proper mathematical conventions, negative 2/5. So the coordinates for the x-intercept will be when x is negative 2/5, y is 0. So they're my coordinates for my y-intercept. When x is 0, y is 2. And these are my coordinates for my x-intercept. When x is negative 2/5, y is 0. There's my x-intercept, the point at which the line crosses the x-axis, and here's my y-intercept, the point at which the line crosses the y-axis. Terrific, and we can work that out from the rule. If you've got the rule, therefore, you can work out the y-intercept and the x-intercept, and it'll be really easy to draw a little graph from there. So basically, if we had something like this, we know that it's going to cross the y-axis at, let's make that one, we'll make this one 2. It's going to cross the y-axis at 2, and it's going to cross the x-axis at not quite 1, so about negative 2/5 is there. And so we just join them up. And we've got a little line. So as you can see, the way that's been divided, it's a pretty steep line, but it's still got a positive gradient.